Okay, we're gonna continue reviewing. Here's 3.5 and 3.6. This was, adding and subtracting, multiplying, dividing, and doing composition of functions. So, how do you add two functions together? Well, it's saying f plus g, you're gonna take this and combine that, and you should get, for this one, x, all you do is add the like terms. That's your answer. Now the subtraction one, make sure you distribute the negative. It's telling you to take g of x and subtract f of x. So just make sure you distribute the negative, and you should get x, negative x squared plus x plus 6. For the multiplication one, you have to FOIL. You have x squared minus 9, and you're gonna multiply x minus 3. So make sure you FOIL correctly. X cubed minus 3x squared minus 9x plus 27. The division one, when you divide, make sure you can, if you can factor anything, this one's saying x squared minus 9 over x minus 3. You want to simplify, the top cancels because it's factorable. So you can cancel those two out. So your answer is x plus 3. Now the domain for this one, the domain for the previous ones were all real numbers. Okay? But the domain for this one is all real numbers except 3. You can't have a 3 here because it's a fraction. And now, how do you do these composition ones? G of f of x. This is saying take the f function and plug it into the g function. Well, here's the f function. If you plug this into g, right here, you get x squared minus 9 minus 3. So x squared minus 9 minus 3. So your answer would be x squared minus 12. Then how do you do f of g of x? You're going to plug the g function into the f function. Well, here's the g function. When you plug this in here, you're going to do x minus 3 squared and then minus 9. So you'll have to FOIL this out and then subtract 9. These cancel. So your answer is x squared minus 6x. This one's on your test, these where you have to evaluate. For number 12, you're going to plug negative 1 in the f function. If you were to plug negative 1 in here, you get 4 over negative 1 plus 2, which is 4 over 1, which is 4. And then you plug 4 into the g function. So 4 cubed plus 2 is 66. Next one, you're going to plug 0 into the g function, evaluate it, you should get 2. You plug 0 into the g function, you get 0 squared plus 2 is 2, and then you plug 2 into the f function, 4 over 2 plus 2 is 4, which is 1. Number 14, they're telling you to take 3, multiply it by, well actually you're going to take 2 and plug it into the g function. So if you plugged a 2 in here, 2 cubed is 8, 8 plus 2 is 10. So you have 3 times 10 minus, this you're going to plug a 0 in the f function. If you plug 0 in here, you get 4 over 2, which is 2. And then plug 2 in the f function again. So 2 plus 2 is 4, 4 over 4 is 1, so this is all 1. So 30 minus 1 is 29. You're not going to have to split functions on your test. You're not doing it at the next one. Number 16, is this 1-to-1? Yes, it does pass the horizontal line test. That tells you when you do the inverse of this, its inverse will be a function. Number 17, how do you find the inverse of a graph? What you're gonna do, and I'm just gonna show you really quick, you're gonna take all of these points right here, which I would say this one is -6, 1. I would do this point right here, which is -2, -4. And I would do 0, 0. And I would do 2, -1, and 4, -1, or 4, 1, sorry. That's that point. And now, to do the inverse of this, you have to switch all these points around. So in other words, you're gonna graph 1, -6. Okay? Here's 1, -6. You're gonna start there, then go -2, -4, 1, 2, 3, 4, which is right, it's gonna connect right there. Then you're gonna do 0, 0, which is right here.
Wait, for that one, why did you do negative?
I'm sorry, -4,
Yeah.
I knew that was wrong.
Yeah.
So -6, 1, 1, -6 is the first one. I have to go -4, 1, 2, 3, 4, -2, that's that.
That's positive 2. You said -4, -2.
This is negative,
Yeah.
oh my gosh. Yeah, it's right there. -4, -2. Then 0, 0. Then -1, 2. And then 1, 4. There. Now it's better. So for inverse, you just switch x and y around. Now, how do you do the inverse of a function? Okay, so now see this? This is a parabola. It's a quadratic. And when you do this does not pass the horizontal line test. So its inverse will not be a function. So you can't use f-1 of x on this problem. You can't, because its inverse won't be a function. It's gonna be on its side like this, and it's not a function. So, but we can do the inverse of it. We can get a rule. And how you do that is you're gonna switch x and y around and resolve for y. So add 4, and then square root both sides. And don't forget plus or minus. So your answer is plus or minus x plus 4 equals y. And if you want to write it the other way. So that's the inverse of that one. Now for the next one, you have a line. You have y equals 3x minus 6. Now this, a line, is its inverse, it's 1 to 1. Its inverse will be a function. So when you switch your x and y around, you're going to add 6 and divide by 3. So you have y equals 1/3 x plus 2. Now, this is an inverse, so you are going, this is a function, the inverse is a function. So you do that notation when possible to designate that this is the inverse function. So you're not gonna, for number 20, you're not gonna have to do a proof, so obviously I'm not gonna do this problem, number 20. It's not on your exam. A proof is not, you just have to know how to do the inverses. Chapter 4. Everybody on 4-1? For 1 to 4-3. Everyone have this in front?
Mm-hmm.
Okay, next. Is this a polynomial? It is. Polynomials have all, look at your x's. As long as your x's are in the numerator and they have a positive, a whole number I should say, not whole number, yeah, whole number. Whole number is the exponent, then you're good. This is meant to trick you. This is 1/3. That's okay. So you can have fractional coefficients, you just can't have fractional exponents with your variables. So it's all about the variables, as long as they're not decimals, negatives, fractions, or you can't have this. That's actually a fractional exponent. So this one was good. And what do polynomials look like? They're curvy. There's no breaks, there's no sharp corners, there's no turns. It's very curvy, no breaks. So this is a no. How do you do synthetic division? Okay, you're gonna take well, first of all, you only can do synthetic division if the divisor has a degree of 1 and the leading coefficient has to be 1. You put a 2 outside, and all the coefficients in order. So you should have a 1, 0, 0, -3, 1, 7. Synthetic division, you bring down the first term, you multiply, add, multiply, add, multiply, add. Keep doing that. Oops. What did I add wrong? 4 times 2 is 8. That's 5. Oh, I forgot a 1. Got a 1. 5 times 2 is 10. 11, 22, and then 29. So your answer is going to be 1 degree less than this 5, so it's going to be 1, these are the coefficients. The answer is going to be x to the 4th plus 2x to the 3rd plus 4x squared plus 5x plus 11 with the remainder of 29 over x minus 2. Number 4, using the factor theorem, you're going to plug -1 in here. You're going to evaluate this for -1. And you should know a -1 with an even power is a positive, so it's going to be 7. This is going to be a negative, but this is going to cancel, so you get +3, and then +5, and then +1. Adding these up, you get 16. So if you would have gotten a 0, you would say yes, this goes into that. But since you got a 16, what is the remainder? The remainder is 16. And if you want to write 16 over x plus 1, that's fine. Number 5, you have to do long division. You have x squared plus 0x plus minus 8. That is going to go into x to the 4th plus 2x cubed minus plus 0x squared minus 16x minus 17. So how do you do this problem? You want to get rid of this right here. So you're going to put x squared here. X squared times these 3, you get x to the 4th plus 0x cubed minus 8x squared. Now what do we do with this? We subtract. When you subtract, these cancel. You get 2x cubed, and this is going to become plus 8x squared. Bring down the next term. Now we want to get rid of this. So x squared times 2x is going to eliminate this, make it 2x cubed. Now continue to distribute, plus 0x squared minus 16x. When you subtract, you get 8x squared. These cancel, and then bring down negative 17. Now what do you need to multiply x squared by to get 8x squared? You need an 8. 8 times x squared is 8x squared, and then we have 0x, and we have minus 64. So now when you subtract these cancel. This is going to turn into a positive 64. So negative 16 plus 64 is 47. So 47 is your remainder. So no, it does not go into it evenly. We had a remainder of 47.
Is it alright if we just use like the 47 as a remainder, not 47 over whatever?
Well, look at your question on your test and it'll be one of the two,
Alright,
okay? Find the polynomial, it says don't FOIL it. What are these two zeros right here? -1 and 2. So how are you gonna write this? You're gonna write y equals x plus 1, we have to square it. Why? Because it's touching here, bouncing off. And then x minus 2 squared. And also, you have 3 max and mins, both sides are going up, the degree is 4, so it makes sense. Number 7, find a 5th degree polynomial with zeros at 3 and -2. So we have a 0 at 3, so you're gonna have x minus 3, and you're gonna have x plus 2. And it's saying we want a degree of 5, so these two powers have to add to be 5. So if it's gonna cross at 3, it's crossing here and it's touching here. This has to be an even power, and this has to be an odd. Now, you could have had another answer. You could have had a 1 here and a 4 here, and that also works. Don't worry about 8, you don't have to do it. Upper and lower bound, this is on your test. A negative number can only be a lower bound. It can be this, so it can't be that, upper. An upper bound is a positive number test. So what you do is you take -4, and to see if it's an upper or a lower bound, because it can't be upper, you're gonna do synthetic division. If you get checkerboard, plus, minus, or minus, plus, one of these two, then it would be a lower bound. But what happens here when you bring down the 1 and multiply and add, and multiply and add, you get, these two are positive, so it's neither. It can't be an upper bound because it's a negative number. And it's not lower because of these two are both positives. These are both positive numbers, 1 and 16. When the multiplicity of a 0 is odd, what does it do? It crosses. It crosses. If it were even, it would touch and bounce off. Number 11, how do you do the possible 0 test? So you take factors of -3, of 3 and 3 over 3, so plus or minus 1, plus or minus 3, over plus or minus 1, plus or minus 3. Factors of the numerator over factors of the denominator. And one by one, you're gonna start the process. I always start with 1, and 1 worked on this problem. You're gonna use synthetic division. One of these is on your test. Bring this down, multiply, add, multiply, add, multiply, and add, and there you go. That's your first 0. It says find all the rational zeros, so 1 is a 0. Now what you have here, you have a quadratic formula that is simply factorable. And your other two zeros are 1/3 and -3. And these are rational. They're rational. The irrational ones are the plus or minus square root ones. So 1/3 and 3 are your other zeros. Now real, when it says real, it wants all of them. The irrational and the rational ones. So again, you do the possible 0 test, try 1, 1 doesn't work, you try 2, 2 works, and I'll show you really quick. Bring down the 1, 2, 4, 8, -3, -6, 0. So it worked. So 2 is a real 0, and now what you have here is 1x squared plus 4x minus 3. Now, it looks like it's factorable, but it's not. So you have to use the quadratic formula, or you can complete the square. I like completing the square on this one, add 3, bring 3 over to the other side. Half of this squared is 4, add that to both sides, factor. Square root, you get x plus 2 equals plus or minus root 7, and bring 2 over. So your other two real zeros are -2 plus or minus the square root of 7. So there's 3. These are all real. Now, if you had a negative underneath the radical, that's imaginary, so that's not real. Okay. Number 13 is the same problem. It's just, can you find, this is testing you to see if you know the difference between a rational, a real, and how to factor it completely. To break it up. Once you find your zeros, how to break it up. So, I'm not going to do it, because it's a repeat. Number 14, use this graph. This is a good question, because it'll touch you on all these things. Okay, so, if you look at, what are the zeros? I always start with that. What are the zeros? There's 1, there's 1, there's 1, and there's 1. So the zeros are -3 in order, -1, 2, and 3. So the degree has to be bigger than 4. How do I know that? Because it's touching here and here. And it has to be an even degree because both left and right are going up. So if it's not 4, what is it? It's 6. You have a 6?
No, I had it. I had -3 plus or minus.
Okay, show me after. Okay, is the leading coefficient positive or negative? It's positive. If both sides were going down, it would be a negative. Now, the max and mins, it's going to be 1 less than the degree, so it's 5, and the number of inflection points are 2 less than the degree, so 4. Now, how do you write the function then for this? It's going to look like this. Y equals x plus 3, x plus 1, x minus 2, and x minus 3. But what we have to do is we have to put a 2 with the -3 and with this 2 because it's touching here. If you have multiplicity that's even on that. Number 15, state the zeros in order as they appear. 1, -2, and 3. Then it also is asking you, what's the multiplicity? Well, 1 is occurring 2 times, so this is even. This is odd. And this is odd. And what does it tell you? Here, it's going to touch at 1. It's going to cross. And it's going to cross. So why do we need this information? So that way we can graph these ones. And Tara, this is what you were asking. So on your test, you can easily pick out which is the right answer based on, you want to look at the degree of the whole problem. It's a 4, 2, 3, 4. The degree of this is 4. And it's a positive leading coefficient, so it's going to look something like that. We have zeros at 0, -2, and +3. And I know at 0, it's going to touch here. So what's going to happen is this thing's going to come down, it's going to touch at that, and it's got to go back up. So look for something with that shape. You're not going to have to do more than that. You're not going to, I had you do more on your test here. I made you pick numbers between 0 and 3, remember that? I wanted to see how far down, you had to make a T-chart, but you don't have to do that. This one, you're going to want to factor it, take out an x squared, and factor it completely. The only difference between that problem and this one is this one's not factorable. And so you do the same thing. You have a 0 at 0, -3 and 2, and it's up, so you should touch at 0. So at -3, I have to put my glasses on, guys. At -3, 2 and 0. So this one's gonna look like, it's almost similar to that last one. It's like that. Questions? Done with 4-1 to 4-3. Remind me after now. Okay, 4-1. Okay, what's next? We have this one. 4-5, 4-6. I'll do that after. I'll do that one after. Okay, how do you do these problems? Okay, how do you add or subtract? Well, this one's easy. You're gonna distribute the negative, and you have to multiply the two. So 18 minus 12i minus 6 minus 4i. Collect like terms. Believe it or not, one of these is on your test. Add these two up and you get 12. And add these two up, you get -16i. The next one, number 2, you're gonna FOIL. 3 times 4 is 12. And then minus 18i plus 8i. And then what's 2i times -6i? It's -12i squared. What's I squared equal to? What's this whole term gonna go to?
12.
This is gonna be really a 12. And so 12 and 12 is 24. And add these up, you get -10. -10i. Next one. You wanna convert the square root of -12. So it's I root 12. And you're gonna pull a 2 out, so it's 2i root 3. So this is, you get 4 plus 2i root 3, plus, you're not multiplying, plus 3 minus, now this, you should clean this up, you get minus 6i root 2. You guys had trouble with this one? The only things you can add are the 4 and the 3. You get 7. And we're done. Number 4, you've got to simplify -√18. It's 3i root 2. And now you're going to multiply it. You can't do anything with that, but this you can simplify to be 2i. So, distribute. This times this. This 2 comes out, you get 6i. This becomes 6i. And then this times this. 3 times 2 is 6. You've got a couple of i's, so that's I squared, and then root 2. Now, I squared is -1, so this is going to become a -6. Next one, you're going to have to, some people can do the shortcut. You square the first term, you multiply these two together times 2, and then square the last. But if you can't, you have 2 of these quantities. You're going to FOIL. 3 times 3 is 9. You have 6 and 6, you have 12i, and then you have 4i squared, and I squared is -1, with a 9 is 5. And number 6, this simplifies to be 2i root 6 minus I root 6. And now these are like terms. 2i minus 1i is I root 6. Questions? Number 7. Number 7, you have 10i, simplify that over 7i. These i's cancel, and you just have 10/7. Number 8 is on your test for sure. You've got a huge power. So what you do, we know what I squared is. So 2 goes into 105 52 times, but there's 1 left over because it's an odd number. Now what we're gonna do is rename this as -1. If we took -1 and multiplied it an even number of times, it'd come out +1. So your answer is I. Remember, this answer, it's plus or minus 1. Those are 4 possible answers. So it'll be multiple choice. It'll ask you, is it 1, -1, I, or -I? Number 9, how do you rationalize the denominator? This is on your test. You multiply by the conjugate, 3 minus 2i over 3 minus 2i. Let's see what we get. 4 times 3 is 12. You're going to distribute minus 8i, minus 3i, and then minus 2i squared, which if you want to just write plus 2 here, you can. Plus 2i squared, so this is going to be a -2. -2 plus, well, let's add that after we do the bottom. 3 times 3 is 9. The next 2 cancel, and then you have minus 4i squared. So I got, for this one, this is going to turn into a -2. -2 plus 12 is 10. And then minus 11i. And then the bottom, this becomes a 4. 9 and 4 is 13. You're off the hook for 10 and 11 for your exam. Number 12. How do you do this problem? Well, it's all it is the quadratic formula.
I think there was like a test question one time when we were taking some tests. I can't remember which one. It said give all the solutions, but not like imaginaries or something.
Well, when it says find all real and imaginary, you do, if you get an I in the problem, that's what you put with that answer. Is that what you're asking?
No, but it was a
If you
weird
can
question.
find it, let me know.
Yeah.
So what you have here is -2, because B is 2. It's -2 plus or minus the square root of, you're gonna have 4 minus 4 times 1 times 5. 2 times 1 is 2. And then what you have here is -2 plus or minus. This is gonna be -16 when you do everything. And the square root of -16 is 4i. And now simplify it. These cancel, so you have -1 plus or minus 2i. These are imaginary zeros. Number 14, skip 13. 13, it was a typo. I forgot the x after that 24. What you were supposed to do is factor a 3x out, and you have x cubed plus 8. And then this was a perfect square trinomial. Remember how this factors? X plus 2, x squared minus 2x plus 4. And then your zeros are 0, -2, and then this one you had to use the quadratic formula or complete the square to find the other 2. And to do that, you are going to bring 4 to the other side. Half of this square is 1. Factor, quadratic, square root both sides, so you get x minus 1 equals plus or minus root 3i, and then add 1. That's what you guys missed out on. So there's 4 real and imaginary zeros. It was 0, -2, and then plus or 1 plus or minus square root of 3i. For number 14, this one you are going to, it's an x to the 4th. We did one like this in chapter 2, but we didn't talk about imaginary ones in chapter 2. So now we're going to do these problems incorporating imaginary. So when you see a problem, there's one of these on your test, x to the 4th, split it up. How do you factor -6 so you get a 1 here? It would be +3 minus 2. Now set each of these equal to 0. So subtract 3. Square root both sides. So x is plus or minus the square root of 3i. And on this side, add 2. Square root both sides. You get x is plus or minus the square root of 2. So there's 4 answers. These are imaginary, and these are just, they're real, but they're irrational. Okay, the next one is on your test. Make sure you can do this problem. We have a degree, a polynomial with a degree of 4. One of my zeros is x minus 3, and one of them is imaginary, 4 minus I. Do we know another one automatically? Yep, because imaginary ones come in conjugate pairs. So now, how many zeros do I have right now? One, I have 3 of them. How do I get this problem to be a degree of 4? What am I going to do?
X plus 3 squared.
Yep, you're going to turn this one, it's going to bounce, touch and bounce off that -3. Now, how do you write the other 2 zeros? It's x minus 4 minus I and x minus 4 plus I. Now, you are going to have to, for me on your test, get rid of these i's. How do you do that part? Well, what we did in class is we distributed the negative, x minus 4 minus I. We regroup these so we can FOIL it easy. If you multiply these two together, you get x minus 4 quantity squared. The next 2 cancel out because it's the difference of 2 perfect squares, and then you do I times negative I, which is negative I squared. So now, simplify this. This is going to be plus 1. So it's x squared minus 8x plus 17. So your answer in factored form would be x plus 3 quantity squared, and then times x squared minus 8x plus 17. Questions? Okay, you don't have to do 16. You're good on that one. For number 17, if negative I is a 0, what other 0 is there?
I.
And you have I. So what you have is x minus I and x plus I, which if you factor this out, you get x squared plus 1. So this is a factor of this. So what you could do is take this, do long division. You're going to do x squared plus 1. You're going to take that and divide it by x to the 4th minus x cubed. And what you end up getting here on top, after you do it, I'm running out of time, so I'm going to go quick, x squared minus x minus 6. Now what you're going to do, to find the other 2 zeros, you're going to factor this, x minus 3 and x plus 2. So your other 2 zeros are 3 and negative 2. So the 4, because it's a 4th degree problem, there's 4 zeros. They gave you negative, they gave you a hint. If negative I is a 0, so is positive I. And then 3 and negative 2. And for 18, I'm going to go quick on it. They tell you 2 is a 0. And if 2 is a 0 twice, they said multiplicity 2, what you do is you can use synthetic division and divide it out. You're gonna get a 0 first time, and you do it again, because it says it happens twice. Take this answer and do synthetic division again, you're gonna get another answer. This is the little treasure you're looking for right here. You're looking for 1x squared minus 2x plus 17. Now with this, you're gonna have to see what the other two zeros are. Because it's not factorable, use the quadratic formula, and your other two zeros should be 1 plus or minus 4i.